Okay, dear learners, we are now here to learn another topic of this unit, that is the iterative refinement. This is the last topic of this unit. Now, in iterative refinement, actually what you're going to do is you will be calculating the number of computations required to arrive onto a solution with the maximum accuracy. Okay, so here is a question for you. Find the number of correct iterations required for the following system of linear equations, that is A, B. The solution accurate to 4 decimal places is 1.3636 minus 0.1010 and minus 0.3232. Okay, so this is the accurate and the correct solution. But here you have something known as a computed solution. That means the solution that we got after the first iteration. So from this solution you need to reach this solution, and you need to identify the number of iterations required from this to this. Okay, so that is what your question is. Let's see how it is being done. So please identify the question properly. This is the coefficient matrix and this is the constant part, and this is the value for x, and this is the accurate, the correct answer. Okay, now we are going to see how it is being done. So the first thing that you are going to do is you will be just writing it in the matrix form and the equation form. Then first what you do is you will start with an approximate solution. That means x1 is 1 0 minus 0.05. So this is actually an initial guess which is already being given in the question itself. Now what you do is you have an equation known as R, that is the residual is equal to B minus AX1, isn't it? Why this residual? Because if the solution is perfectly satisfying your equation, means you never need to bother about a residual. But since it is not satisfying the equation, you definitely will be having a residual, and that's why we are not going to get B minus AX is equal to 0. Rather we will be getting something known as a residual, and that residual is being calculated by doing the sum. That is, you are going to write B, you are going to write A, and you are going to write this x, and you are going to multiply A and x, and you will be calculating the value as 1.5, 0.5 and 2. So this will give us an idea that how far is our initial guess is from the actual solution. Now next we already have this A, the residue R1, and now what you do is you simply solve for a temporary value of this xyz, that is x bar, and which will yield you the value that is the residue. Okay, so this is actually you're going to yield the residue when you multiply with this particular x, y and z values. So we are actually going to find these values now. Now once you solve it, you'll be getting the equation as the del x1 will be minus 0.3636 minus 0.1010 and 0.1768. Afterwards what you do is we add this small change in x1 to the original x1, and we just observe that this x2 value, that is after this first iteration, we get a value which is exactly equal to the actual solution that is already being given in the question. Okay, so hence we can conclude that just after one iteration you will be able to get the final answer, and so you will be getting the correct solution in just one iteration. Okay, so that is about this topic. Thank you.